All right, welcome to CMS 3355. We're going to go ahead and get started. Hope y'all are doing great. It is Monday. Let's get started. Today we're going to be talking about version control system. So I would encourage you to make sure you download your favorite Git client. I think SourceTree is a good one, but there are many good Git clients. Let me send you a link for SourceTree. SourceTree is a nice one. I am putting that link in Slack because we're going to be using it today. I'll put it also right here in YouTube. Anyway, SourceTree app, check it. We're going to be using it today. Download it and install it while you're listening. A few things to announce. First of all, the Xfig assignment is done. So Xfig should be compiling and running and installing on your machine. So if you don't have Xfig running and installing and updating on your machine, then you are in a bad place and you really need to get that happening. Talk to the TAs. If the TAs cannot get your case to work, then talk to me. But you really need to make that happen like ASAP, because if you don't make that happen, these chances are you're probably going to fail this class. It's just no other way to say it. You need to make that happen on one machine. You don't, if somebody mentioned they had it on their home machine working and then they were also trying to get it running on a laptop and we're having trouble. If that's the case, I'd encourage you just use it on the machine that's working. Don't waste your time trying to get it set up in multiple places. So, you just needed to work on one machine. And yes, somebody's asking, can we use GitHub Desktop instead of SourceTree? Absolutely. If you want to do that, that's fine. There's some challenges to GitHub Desktop, like you have a little bit less access to some of the sophisticated things, but anyway, it's up to you. The assignment 1 for Android will be out on Wednesday, and the groups are all finalized. So, let me know if those things are not true for you, but everybody should have a group member, a group mate, and we should have Android assignments, the first assignment going out on Wednesday, so you know what to work on. It will be a group assignment. Remember, we're only in groups of 2, so it's a group assignment, but it's a group of 2. All right. Last time we talked about Android a bit, and we talked about activities and intents. Activity is a page, and we didn't go as much into details on intents. We might talk about that again in the future. But intents are kind of how you go between pages or things that you want to do. Activities are basically the main thing. Intents are moving between those things. And also kind of how you get stuff done. So make sure if you haven't done Android Studio, tutorial, you should definitely start checking that out because you're going to have to start doing that soon. So make sure you do that Android Studio tutorial so you have a clue what's going down. Okay, so today's lecture is going to be focusing on a kind of a practical use of version control systems. How about, let me see something. So we're going to be using specifically Git because that's kind of one of the most common version control systems used today. So it is a fairly complicated one compared to others, but it's kind of the de facto standard. So we're going to learn to use it. A little bit about these systems. Back in the day, single developers could do the whole system, right? If it's a small enough assignment, you could just get what is, let me turn on my drawing here. All right, so it used to be that you could get a superhero to kind of take charge of your project and do it. Can anybody guess what a superhero in the context of software engineering is? Can anybody guess? Put it in the chat. What do I mean by this superhero programming error? Like, what do I mean by a superhero? Yeah. the one guy that does anything and everything. And more specifically, what I mean by this is somebody that could basically just do it all themselves, the entire project themselves. And, you know, nobody else really needed to do anything. However, the deal now is that that era of software making is more or less over. I mean, okay, for some small apps, very small apps, like maybe even Git itself, right? One guy basically made that. But for most apps, you're going to have a team of people working on it. Like SourceTree app, that has a team of people working on it. Any app on your phone, like your Facebook app or Instagram app or whatever, that has a whole team working on it. There's just so much functionality and quality that needs to go into it that you can't do it yourself. If you want to have a successful programming career, you need to have programming chops. But that's not the only thing. Perhaps as important, or maybe more importantly, is you need to learn to play well with others. Guess what? Many computer scientists never learn to do this, and they suffer for it. And they hold themselves back. And like very brilliant programmers often don't get promoted because they're jerks or because they can't work well on a team. A good way to look at it is, imagine you're at work and you are on a team and you make excellent, elegant commits. Your code is perfect. Your code always runs. Everything's amazing. But your project stinks. All the rest of your team stinks. They are doing bad check-ins. Your project doesn't work at all. Do you think in the next year you will be promoted? The answer is no, you will not. If you are on a team that is losing and doing bad, I bet you nobody on that team gets promoted that year. So you need to not only do well yourself to get promoted, you need to make sure that your coworkers and everybody around you is doing well. There are essentially no winners on a losing team. And this is super true. I've heard of this inside of places like Google all the time. Like, yeah, well, that person got ahead because they happened to get on this team, and that team, delivered this product which everybody uses, and so they kind of rode the success of that product up the chain. The converse of that, though, is this person who was very good got on this bad team and wasn't able to help everybody else get better, and so they never got promoted for years, and they didn't have enough people skills to like get themselves transferred off of that team, and so they never kind of moved their career forward. Now, I want you now to imagine, we've talked about how you could have a bad career even if you have great technical skill. How do you think you could have a good career even if you have somewhat limited technical skill? So, maybe you're not the best programmer ever, but you're a decent one. And you understand how everything kind of works, and you have a CS degree. How do you think you could have a good career, even with relatively limited technical skill? I'll give you all a minute to get them in there. We got a fair amount of people here on the stream, so I'm going to give you all just a second. Got some funny ones in there. All right. So, good answers, but let me give you another angle on this. It's not, of course, your attitude and a lot of these things are going to help you. Teamwork can help you. But what I was getting at is if you're somebody that can do things like work within a group, effectively organize a group, effectively communicate within the group, effectively communicate outside the group, there are many roles that could fit you very well, even if you're not coding every day. There's things like product owner, product, what's the other one? Essentially, the person that helps talk to customers and get requirements versus the person that helps organize the sprint internally versus the person that's managing developers, people that are kind of helping people use the software. There's lots of things around software development that you can only really do if you have a technical background, maybe not the highest technical level of skill, but you can communicate with people and work in a team and things like that. So even if you don't think you're going to be a hardcore computer scientist, pay attention to this stuff because you need to know the basics of it, and then you can still get great paying jobs. If you have some baseline of competency, but you wouldn't have to code every day. Okay, so getting back to the fact that we can't make software by ourselves anymore. Here is a brief timeline of video games over time. Space Invaders back in 1981, it was made for arcade console, had a development team of one person. That is why when you guys all and gals make software in these classes by yourself, the outcome is not always that impressive, right? Because it takes more than one person to make something interesting. Super Mario Brothers, which you may or may not have ever seen because you guys are super young, that took 8 people to develop. Okay. Fast forward to 1999, and the state-of-the-art game then took 30 people to develop. And looking forward to 2013, Resident Evil 6 had a much bigger budget and 600 people. Okay, so now when we're talking about people making things like great video games or great apps or great software, it takes a ton of people. Can't do it by yourself. Now, I want to take a brief aside here to mention, while we're talking about video games, how many of you want to be a video game developer? Just out of curiosity. Does anybody want to be a video game developer? Let me know in the chat. How about? Does anybody want to be a video game developer? All right. So some people are saying, yeah, maybe. Nobody's saying like absolutely, but a lot of people are saying, yeah, maybe. I want you to understand though that industry is a little bit different than you might think. Let's take a quick look, real quick. I'll put this in the chat too. This is just an aside at that industry. This is just a day in the life of a professional video game developer. And I want you to look through this in more detail later, but this person just taking you through a day in their life. They get up at like 6 a.m. And they do some things, but they start working pretty much immediately. Okay. At 7 a.m., they've answered all their important emails and they start drinking more coffee. By 8 a.m., they've done 2 hours of light work and they are ready for breakfast. Okay. They have meetings at 9. Now they may take some time for exercise here, but they're more or less working. And then at 10 a.m., Remember, they got up at 6 a.m. At 10 a.m., the real work starts. Yeah, they do have a lunch break, but they continue working on until about 6. And then from about 6 to when they go to bed, which they say is 10, they, mainly stay away from work. However, they often end up writing emails or talking with clients late into the evening. So, this is a pretty long day. I personally work about 8 to 5 every day. This person works from about 6 to about 6. And, they admit somewhere in here that they work something like 11, 12 hours a day. So just something to know about the video gaming industry. While you think it is like glamorous, they say 11 hours, I think. It is not always super glamorous, and it is something that requires a lot of time. Perhaps it's okay when you're single and young, but it's something that if you're going to have a family and have any kind of work-life balance, it may not be for you. Now, this is just one video game company. Of course, there are some that are quite reasonable, but this particular one in this industry in general is a little more demanding than others. Okay, that was a sidetrack, but I just wanted you to know that video game development may not be all it's cracked up to be. Okay. Today, we're talking and we're focusing on version control systems. This is a necessary tool of the trade. This is how we can collaborate with each other. We put the code in basically a centralized location, and it provides us with a version or a snapshot of the code. Importantly, it also gives us a copy of every version file. You can always go back and look at old files and things like that. But the key ideas here are it's a centralized location to store all the project files, provides you kind of access to the current version, to older versions, and you can look at all the history of all the versions. Now, why would you ever use version control? Well, of course, you need to keep your code safe somewhere. You may want to, if you introduce bugs into your system, you may want to, of course, roll back. Oops, I didn't write that, but roll back. You may actually have two branches in your control system, like one where there's development branch, and then like another branch that is for deployment. You may want a history of who did what and when, so you can figure out when bugs are in the field and when they aren't. And of course, it's really good to track what happened between projects. So you're just keeping a record of what went on, a way to roll back quickly if something goes wrong, and a way to collaborate. Now, there's a couple different types of version control, and the old school way was to have centralized version control, and that's where the repository exists only on one machine, server with internet access, and you can kind of like check it out from there and make changes and push it back. You can do things like, here are the basic commands: check it out /update. Who can tell me what is the difference between checkout and update? In the chat, what's the difference between checkout and update? Hello, hello, hello. Checkout versus update in the chat. Who's alive out there? Everybody's dead. Update fetches the most recent code. All right. let me give you a high level idea. So these aren't necessarily technical terms, so let's not get too tied up on these being technical terms. But checkout just means the first download of your code onto your machine. Like, I'm going to check out that branch. It's now on my machine. Update is I already have it on my machine and I'm just getting the latest files. All right, so checkout, get it on my machine the first time. Update every subsequent time when I'm getting a new copy, like getting the latest files. Commit is, of course, when another very important thing. That is when if we've changed any files, we push those back to the server. So anything we've changed, we push it back to the server. And then branch is when we change things, like we start from, let me draw this. So like, here's a version of our software, and then, we made a change. Here's another version of our software. We made a change. This is just a graph of the software. Imagine you get here and you say, I want to make a new branch. Well, your regular branch continues. It's right here. And then you have a new branch right here. And this is another version of your software. Right now, these are just differentiated by their name, like branch 1 and branch 2. But in the future, they will actually have different changes, okay? So they'll have different changes in them. This change over here will not be the same as this change. Check that out. Sorry about that. I drew where my head was. My bad. Okay. Now, when we think about centralized repositories, here's what happens. All right, Bob, he's just committing to the server. He makes an update. And then Alice is over here. She takes that update and she changes code, and then she might commit to the server, and so on. Okay? That's the centralized version. Who can tell me what's an example of centralized source code? What is an example of centralized source code? What is an example of a centralized version control system? Anybody know one or has ever worked with one? Well, they're just too young. Okay, so actually, Git itself is a wrong answer. GitHub, on the other hand, kind of. A good answer, and like a correct answer, which would be something that y'all may have never seen, would be something called CVS or SVN. These are old school ways of keeping source code all in one place that were definitely centralized. Now, going back to here, when you have a centralized system, if two developers edit the same file, there is a problem. If two developers edit the same file and one commits and then the other one tries to commit, then they have what is called a merge conflict, and the second developer will actually have to download the changes of the first one, make their changes again, or merge them in some way, and then commit everything back. There is, of course, some tool support for this. There's, automated merge and things like that. But in general, these things are really painful. Merges are really painful. We don't want to do it. It's painful. You want to kind of avoid these if at all possible. Now, I've been talking about centralized versus decentralized just a little bit. Let me go through a little bit the history of things. So there was just basic revision control systems. Every file was versioned. Then there was things like concurrent versioning system, or CVS, which I just talked about. that handled many files and was very popular in the 90s and 2000s, and Subversion, which was slightly faster and was used widely as well. But these were all very centralized, okay? Very centralized, meaning they just worked on the server and everybody committed there. Then, but there was some problems with centralized, let's say. It's good because it's simple and everything like that. However, it could be bad in some cases because there is a bottleneck when there are many people on the team. Like when everybody's committing, it could get kind of ugly. So there was, and I think actually, so these are the things that are maybe good about VCS, but the bad was also just like scale. So centralized version control systems, they just didn't scale quite as well. Okay, that was a big problem with them. I don't want any questions. However, what has replaced them is a decentralized version control system, which is Git. Now, Git is decentralized because you have a copy of the entire repository on your machine. So, like, let's say here's the server, here's your machine. You download the entire thing, entire copy there. You do some work there. You even update the repository, so you make your own graph and your own updates there. And then when you're done, you tell the server about your changes, and then it updates its copy. So the interesting thing here, this is called decentralized because there could be, let's say Fred over here is working on his own thing. He has a whole copy of the repository. You have a whole copy. The server has a copy. And so everybody has a full copy of the repository. However, the reason that I say GitHub is like almost centralized is because this is kind of like the master copy, right? This is the head honcho copy. And this is where everybody is going back to. So even though we say that Git is decentralized because everybody has their own copy, I have my own copy here, Fred has his own copy, GitHub itself is somewhat centralized. All right. Are there any questions so far on what we've discussed so far? You can go ahead and put them in Mentimeter. If you have any questions, let me know. Otherwise, we have a class activity we're about to start. What if you want to undo an update that was done like 5 updates ago, and you want to keep all the updates that have took place since that one update? Yeah, so you can do many tricky things like this with, like you can remove commits or revert commits and things like that with the right tools. But it's tricky, but it can be done. No, not like the pharmacy. You cannot go to CVS to get source code. You have to download source tree on your machine for the activity today, like right now. Git clone versus git checkout. Okay, so now we're getting to specific commands, okay, like I was saying. So if we're going to use specific commands from Git, clone is basically what I was calling a checkout, where you're actually getting all of the code down to your machine. Okay, that's a git clone. A git checkout will check out whatever branch. We'll actually just move the current program pointer to whatever branch you want to look at, or whatever node, whatever commit you want to look at in your current branch. Don't worry about this too much. Do we need to be registered on source tree? No, not really. Does source tree do the same thing? VS Code source? Yes, yes. You can use VS Code source control extension if you'd like to. But source tree may be easier. It's up to you. I don't care which one you use. All right, here we go. This is going to be exciting. We are going to try and do some source control stuff together. We are going to go to this repository. I'm adding it in. You guys can request access here. I will start giving you access, and I will hopefully give a few of you access to as like a manager so that you can give other people access. Because we are all going to add all of the class members. We're going to have everyone add a file with their full name.txt and commit it to this source code repository. And once you've done that for yourself, you're going to add one fact about people you know. Okay? So we're going to set this up on our machine. You're going to download this repository to your machine, and you're going to be adding a file name and committing it there. And then for other people's files, you're going to be adding a fact about people you know. Now, I'm going to be right here allowing people to have access. If you have a GitHub ID, why don't you you can put it in the chat, and I'll start adding collaborators here, and then I'll start giving them access to also add other collaborators so that we can quickly add everybody. But right now, somebody put your GitHub ID. There's one. I'm going to start adding people here. And make sure you accept it as soon as you can, because I'm going to be trying to give you access rights so that you can also add people. All right, I'm starting to add people. See? To give you more rights real quick. I thought that from Oh man. Does anybody know how to add people as fellow managers of this project? If you know in the chat how to make you guys also, I do want to give everybody permissions on this, but all right, give me just a second. Give access to GitHub repo via link. All right, so I'm just gonna have to start adding you manually. All right, so I have a repository with 1, 2, 3, 4, 5, 6, 7, 8 people on it. I'm gonna wait until I have 10 here. And all right, so I think I have about 10 people here. What I want everybody else to do, since I can't add you easily as I thought I could, what I want you to do is I want anybody who's not in this list to work with others to create your own repository, and we want everybody to have a repository with about 10 people on it. Okay? So actually hold on 1 second. Let me try something different. How can I do this? Be easier for y'all. What would be y'all? Yeah. All right. Everybody else will just fork and submit a pull request. Let's do it that way. I'm going to continue adding people while we're working, but everybody else just fork and submit a pull request. Excuse me. You are just submitting a text file. All right. Anybody who is added also, see if you can add other people to the repository. See if you have rights to add other people to the repository. If so, please add your friends to the repository. So, for instance, Blue-Eyed Wolves and Klutzy Ninja, can you add people to the repository? Try and do it by going to the Manage Access tab. So everybody that's on the repository already, please see if you can invite collaborators. And let me know in the chat. You would need to go to the Manage Access tab. All right, so it seems like some people can access the Manage Access, so please start inviting your friends. We're going to try and invite everybody. So everybody invite your friends. If you've already been invited, invite your friends. We're going to try and all get on the same repository. I think that's going to be cooler. So everybody invite your friends. Everybody invite your friends. I'm continuing to add, but you should be able to invite your friends, get their GitHub names and invite them. So we should be able in the next 10 minutes to invite everybody. So please, please, please start inviting your friends. I'm going to start inviting people, continue inviting people. Anybody that can figure it out, please start inviting your friends. So far, I see that I'm adding people, but I hope that you all can begin adding people. Looks like Brandon might have figured out how to do it. Remember, invite a collaborator, go here, start adding your friends. I can't tell that anybody else is adding their friends yet. Please keep on trying to do that. Yeah. So just start adding people that you can from the chat. Hmm. All right, I'm just continuing to add people, but I think y'all should also be adding people if you can. All right, so we're up to 27. It looks like somebody else has started to help me add people. That is great. So please continue to help me add. We are trying to add by the end of class everybody today. So when you have access, you should be able to go right here and yeah, just see it basically. Check all of your email addresses. Does Dawson 2 has a pinning thing? Can somebody besides Brandon also help me add people here? Be great. There should be lots of you that should be able to add people at this point. All right, so here's what we're gonna do. Some people have been added, but they can't add others. We're gonna run out of time here to add everybody. Um, so if you can't get added to this repository, I want you to work with people in the Slack to create another repository and do the same exercise, okay? So somebody else can begin creating a repository. Just create a new repository in GitHub and go ahead and invite a few of your friends. As few as 5 would be okay, but you need at least 5 people in your repository for it to be interesting. For those of you that are already in this main repository, I want you to go ahead and start doing what you were supposed to do on the code. So far, I only see that Jordan has done this. So Jordan has said, yo. But remember, I want you to say a fact about yourself, okay? The code is here. Essentially, the code you can clone it here. You can open with GitHub Desktop. You can clone it. I would open it with source tree. Code is here. See, we're getting people that are starting to be able to do it. I'm going to stick around for another couple minutes and add a few more people if you'd like. But remember, you can just, actually, I'm not going to do that. What I want you to do is, like I said, start your own repositories and invite a few friends and get together. Make sure you have at least 5 people, okay? Somebody's asking how to do it in source tree. You can, what do you call it? In source tree, you can just clone it. So you go to the code here, say code, get this, and you'll clone it and it'll download, okay? Do I have source tree installed? No, I don't have a source tree installed myself yet, but I will before next time. You are adding your own file unless you recognize somebody that you know, and then you're going to be updating their file. So these are good facts. I don't live on campus. Somebody says, my roommate is Australian. Somebody else says, I am an intern. Somebody else says. If you know anything about these people, then update their files and say something. If you don't, then go ahead and make up a fact about them, okay? Not a mean fact or anything weird like that, but just a fact. And that is what we're going to be doing. And we're going to try and complete that by the time that class starts on Wednesday. You do not make a branch to make a new file. Do not break a branch to make a new file. You're just going to be simply checking that into here. Yeah, so if you didn't get into this repository, and you got into another repository with at least 5 people that you've coordinated with, the question is, how do I know? Well, we'll be collecting those repositories on Wednesday, okay? You can name the file your own name. Name the file your own name. So we're going to collect those. Just make sure you make a public repository. Yeah, there is some limits to adding collaborators. We may, hit those. So just so you know, that might happen. All right, so we're going to go over how to do this in source tree on on Wednesday. But what I want you to do is, again, like just look at the source tree documentation. You're going to basically be doing things like cloning the repository, getting it on your computer. All right, I'm going to download source tree real quick just to show y'all. It seems like there is a little more confusion than I expected. So I'm going to show you exactly what to do. I'm just going to install it real quick and then I will show you. I'll stay here a few minutes longer than just to show you what to do. In just a second. All right, so I'm going to show y'all the main monitor here. Can everybody see my main monitor? I have source tree. Now, going back to here, I'm going to take the code. I'm going to copy that. And I'm going to clone that path. And then I'll pick just the basic place. I'll actually put that in a GitHub folder. GitHub. And I'm going to hit clone. Now, you can see that I have this on my computer. I can, look at the code. I can actually look at it in the regular thing. And here you can see like a file that somebody else has documented. I load oatmeal raisin cookies. They are the spawn of Satan. And maybe I can say something about, well, I'm not going to do anything here yet. Now, again, I have this copy, and this is all the people that have committed so far. And some people have even created branches and then merged them back in and things like that. Okay. But right now, this is where things are at. Now, if I hit pull, I will pull the latest. And you can see Rebecca has now committed in the meantime while I was doing that. You can see if you want to open the actual files, you can hit Explorer here, and it will open an Explorer view of all the files. If you want to edit the files, in this case, because they're all text, you can just, open them in Notepad. I'll just use Notepad++. Now, I want you to notice when I edit it, I've just edited it, and oops, I didn't save it, sorry. I just saved it. You will see here that I have some uncommitted changes right here that I could later commit. But I'm going to go ahead and discard those because I didn't really want to make changes. All right, all of this is a just a brief walkthrough through how to use Git and GitHub and source tree and things like that. We're going to go over this again because I feel that I'm sorry that the adding of people didn't go as smoothly as possible, but we're going to go over this again at the beginning of class on Wednesday so that y'all can have a good handle on this. This is one of the things that is going to be most confusing to those of you that are outside of the major, is using source code repositories. And so this is something that you're going to have to get used to using, and this is Yeah, it's just a confusing concept. Sorry about that, but it is. All right, so because that was a little more confusing than I anticipated for y'all, I want to make sure I'm going to open it up to questions for the next few minutes before I got to run. Are there any questions that y'all have about what you are supposed to do between now and Wednesday? You can put them in Minty, by the way. All right, does anybody have any questions? You can go ahead and put them in Minty. Any questions on what you're supposed to do between now and Wednesday? No, you would not want to create a pull request. Pull request is a more formal way of committing. You are just committing directly to the repository. So no pull request, just commit directly to the repository. Yes, this is a great question. All I need to do is commit a file with a fact about me to someone's repository. That is exactly what you need to do. The repository does need to have 5 or more people on it, though. 5 or more people on it. Great question. I have no idea what we're supposed to do between now and Wednesday. Okay, if you are on the main repository, then you're supposed to upload a file with a fact about yourself. If you're not on the main repository, work with people in Slack to create a repository with you and 5 other people and upload a single file that just has a fact about you. Okay? Where do we put our repositories of our 5 people? You should put those on GitHub. Just create a public repository on GitHub. Great question. What are we supposed to do between now and Wednesday? Either get on a repository or with 5, like basically get on a repository with 5 people. You can do that. If you're already on the existing one, that's great. If you're not, I want you to create one with your friends, with people in the class, try and join one, and make sure it's a group of at least 5 people. And you're going to upload a single file with just a single fact about yourself. Okay? I had a file with my name in the repo, and now it's gone. Okay, so this is kind of part of the trick of committing up to a server. Probably you discarded changes or something, but you're going to need to figure out how to create a file locally and then how to push it to the server. Okay. How do we make it a text file? Or does it automatically do that? You can just create a, myname.txt. That would be a good way to create a text file. myname.txt. You are teaching yourselves to upload a single file into Git, and we will go over exactly how to use Git next time when we have a repository that everybody has a repository that can get on and upload to. All right, so we will go over what you need to do is just make sure you have that connection to a Git repository by Wednesday, and I will walk you through exactly how to upload and download things from it. However, you need to kind of get your first commit up there on your own. So check it out and do your best. All right, any more questions? While we're hanging out waiting for questions, I will show you. Let's say you wanted to add a new file here. I'll add mine. I'll walk you through adding mine. So if you're still watching, I'll just walk you through adding mine. You could hit Explorer. See this list of files. New. And text document. And I would just type in David Shepherd.txt. And I might even say, I like Doritos. And I hit save, close it, and you'll notice in a second, this will update and it'll say, hey, I have this new file. I could just go ahead and stage it, and I could even go ahead and commit it and say, hey, I like Doritos. I am uploading my file. And I could go ahead and commit it. Now that only pushes it to my local one, and I will need to do a pull as well as a push to put it on the remote repository. And it's going to take a second for whatever reason. Someone's asking, how do you add someone as a contributor to a repository? All you have to do is go to Settings and Manage Access. Settings and Manage Access. On. All right, and that's answered. All right, I think that's going to be it for today. We will be back again on Wednesday to show you more about how to use this. This is tricky. Absolutely, this is tricky. So take your time to do it. If I were you, what credential helper should we use to push? I would just use, oh, that's what's happening. I would just use your regular GitHub login. All right, and trying to get my login to work correctly. All right, and I got to run for today, but we will be back on Wednesday to talk more about how to use this. I'll talk to y'all later.